Welcome back. 238, product of array except self. Given an integer array nums, return an array answer such that answer at I is equal to the product of all elements of nums except nums at I. The product of any prefix or suffix of nums is guaranteed to fit in the 32-bit integer. Okay, great. So we don't have to worry about overflow. You must write an algorithm that runs in O of n time and without using the division operation. Okay, so this might be considered a trivia question, depending on how well you're familiar with products and the intricacies of them in programming problems. So let's think through how to approach this problem. Now, we have some examples here. So nums could be 1, 2, 3, and 4, right? And the output eventually will be 24, 12, 8, and 6, right? And let's say, how do we get to these numbers, right? Well, to get to 24, you do 2 times 3 times 4. To get to 12, you do 1 times, okay, so you're skipping the 2, right? So 1 times 3 times 4. And to get to 3, it's 1. So basically, the reason we can't do division is, the easiest way to do this would be 1 times 2 times 3 times 4. This would be exactly what we want, right? If you multiplied all these, this would multiply out to 24, right? And if you had these in every position, then all you'd have to do is iterate through the array and divide them, right? So 24 divided by 1, divided by 2, divided by 3, and divided by 4 will get us exactly what we want, right? This will equal 24, this will equal 12, this will equal 8, and this will equal 6, right? This would be the easiest version if we could do division. If we could do division, we get this 24 one time, and we just iterate through the array and divide everything by that, right? And then you'd get 24, 12, 8, and 6. And what that does effectively is it removes these factors, right? It would get rid of these as factors. So this, in the middle part, is essentially what we want to end up with in some approach that we have. We want these to be the factors that feed into this position, right? So this would be these 3, this would be these 3, this would be these 3, and this would be these 3, right? Now, if you notice something, you can kind of notice that, well, if it's a product of everything except for self, then it's a product of, at any given position, all numbers to the right and all numbers to the left, right? And we can take this example. Let's take this example here, right? This 1 contributes here and here, right? All these 3 greens, right? It only contributes a single one here, right? And then what happens is these 2 are essentially contribute to here, right? And 1 times 2 would be 3. And then these 2, right? 2 times 3 would be 6. And that goes here, right? So this would be essentially, if I can color code it, the contributions made by these numbers, right? So that 1, that 2, that 3. And if you consider, if we wanted to finish this, let's just move this here as well. If we wanted to finish this out, I'm going to go ahead and delete this. Then the contribution always also happens on the other end, right? So if you look at the 4 here, the 4 Can I use yellow? Yep, yellow is still available. The 4 contributes here once, right? It's a 4 here. These two are the factors that we're looking at here, right? So maybe that, you know, if you do it in your head, that becomes 12, right? And then these two are the factors that are here, get multiplied here, right? And that would be 24. Now, this is, if you're looking at any single position, right? So let's look at the, let's look at this position here, right? If you look at any single position, the contribution of elements of this from the right side is here, right? From the right side, we expect from the right side would be the 3 and the 4, right? If it was product of self, it would be the factors 3 and 4 from the right and the factors 1 from the left, right? And this is what we have here. 3 and 4, I'll just make this red. 3 and 4 come from this right here, right? It comes from this 3 and the 4 being multiplied and positioned here. Right, so this 12 is here. And then from the left side, we just have this 1, right, from here. And that 1 goes into here, right? 1 times 12 is 12. And that works for all these positions, right? So I'm just going to go ahead and take the numbers, right? So 1, 2, and 6, right? These are for every single position, this would be the left side contribution. 24, 12, and 4 would be the right side contribution. And when you multiply these out, you have 12, you have 24, 12, 2 times 4 is 8, and 6, right? And this is exactly what we were looking for here, right? Run out of colors, but we can make that purple, right? This is exactly what we wanted before. So we have contribution from the left and contribution from the right. Now the trivia part is that this is a little bit hard to code, right? So in terms of balancing indices, we're going to have to say this is index 1, this is index 2, index 3, and index 0 is going to contribute to here. 1 is going to contribute to here, 2 is going to contribute to here, 3 is going to contribute to nowhere, right? And what's good to know, actually, is that the product of 1 and anything is the identity, right? So you'll see this in the code, but you know, as we're coding this, let's imagine this was all white. You'll see this in the code, but as we're coding this, there's essentially we could essentially make a dummy identity equal 1 that goes here, right? And identity equal 1 that goes here, right? So then what we're multiplying is, get rid of this. We'd be multiplying 1, 1, 2, 6, 24, 12, 4, and 1. Right? We multiply that out, and the number would be the same because it's the identity, right? So that's the breakdown. All right, so let's look at this in code, right? So what we're going to have here is some idea of, we want some from right contribution, or from left, it doesn't matter which way we start. From right contribution, essentially, make this a multiplied by the from left contribution, right? And you know, that would equal the product of everything except for self, right? So how would we set that up? Let's look at it. So maybe let's look at which one may be easier to code. So from left allows us to go from index 0 and then applying it to index 1 and then index 2, applying it to index 3. So that might be easier. Okay, so let's switch these. So let's think through, maybe there's a results array, and that starts as 1, and that's multiplied by the length of nums, and let's return result. And I'm just going to show you what it looks like here. So result array for the arguments 1, 2, 3, 4 is just going to be a list of the same elements for here, same number of elements, and they're all 1, right? So what's the from left contribution? So from left is for I in range length nums. We want to apply some type of product to the result. So the result at I is going to be multiplied by the value here. And what's the value? Right, so I'm going to use yellow. So if let's say there's a running product, and it starts at 1, right? And it goes here. And it's pushed here, right? Multiplied by 1. And then it gets multiplied by 2. It goes here. Gets multiplied by 3, becomes 6. And it goes here, right? So this 1 gets multiplied by this one, it becomes 1. Okay, so the result is going to be multiplied by the element, right? So the element is going to be nums at I. And oh no, it's going to be multiplied by this running product that we have. So let's call this a left product, and that dummy is going to be 1. Right, so it starts 1. Just to make this clear, it starts 1. This gets set to 1. It gets multiplied. And then left product is multiplied by nums at I. Right, so that becomes this, starts at 1, becomes this 1 again, becomes this 2, becomes this 6. Right, so let me just print it. So what we should see is 1, 2, and 6. Right, so we have it starts at 1, and then it becomes 1, 2, 6, and we should not have seen a 24 here. We should only see a 6. So let's look at this. So, oh, well, the 24 is unused, right? So this might be a confusing print. A better print might be here, right? So result I is multiplied by the left product, right? So 1's going to be multiplied by 1, as we see here. And then 1 is going to be multiplied by 1 again, and then it's going to be multiplied by 2, and then it's going to be multiplied by 6. I don't know why result I should be changing. Oh, right. No, this is totally, yeah, this is exactly what we expect. Right, so in the beginning, it's all 1s, right? So it's going to be 1, 1, 2, 6. Perfect. Multiplying by 1, multiplying by 2. Perfect. So this is on the left side, right? So at the end of this, right? So if at the end of this, when I print result again, it's going to be exactly what we drew out, where it's going to be 1, 1, 2, 6. Perfect. So let's do the same thing for the right side. So right side is a little confusing because we have to work backwards, right? So we're going to go from here, index, which is essentially -1. We're going to keep going backwards, right, until the end. So the way that we're going to do that is we're going to take range. Range is going to start from -1. So it's going to be that length of nums minus 1 is where it starts. The direction, the step, is going to be -1, and the stop is going to be -1. Right? Actually, this is the stop. So it's the stop that's the exclusive. So it's going to stop at index 0, and it's going to complete index 0, and it's going to go backwards. Right? So let's print this just so you know. So index equals I, and we'll start going rightwards, right? So when we start going rightwards, the index is going to start at 3, 2, 1, 0, right? We're going to see all 4 of these. Perfect. So we can do something with this index, right? So we can take that result, we can multiply it by this product that we have here, where 1 is the identity, right? So it's going to be the same thing as here, where we're going to multiply by 1, right? It's going to be put here, and then that's going to be multiplied by this number 4, right? It's going to equal 4. 4 is going to be put here. That's going to be multiplied by this number 3. That's going to be 12. 12 is going to be put here. That's going to be multiplied by this number 24, and then 24 is going to be put here. Sorry, it's a little bit messy. Okay, so result, that's going to be multiplied. So we can also say, and star right product, and the right product. Right, so this should be the exact same as the diagram that we have, where we're multiplying by 1, then we're multiplying by 4, we're multiplying by 12, we're multiplying by 24, right? So these are the two sets that we have here. Multiply by 1, 2, 1, 1, 2, 6. That's exactly what we have here, 1, 1, 2, 6. And then 1, 4, 12, 24, right? So we have 1, 4, 12, 24, and that's backwards. And this is actually the results array. And that's already, right, we can return that. Okay, great. So let's run this and see, oops. We don't need these. Let's run it again. And submit. All right. Pretty good solution. And it's solved for it's solved for us. The only optimization I could think of, be a miniature optimization, is to get the lengths and store it. So store it as some type of n. And then the other one that I can think of is, that's it. All right. Thanks.